The nature of architectural practice is undergoing rapid change and evolution. The increasing adoption of digital workflows within the design and construction industries, including digital fabrication, direct manufacturing, artificial intelligence, and other emerging technologies, presents both significant challenges and opportunities for the practice of architecture. This paper will explore the implications of the adoption of new technologies on the practice of architecture. This discussion will be grounded in recent research into the impact of the adoption of digital fabrication processes within the profession in Australia. We will attempt to demonstrate a gap in the knowledge around how technological shifts in the procurement of architecture might shift the model of practice. We will argue for the importance of architectural education in shaping the future of the profession and demonstrate how these possible futures have been modelled through the teaching program at RMIT University. Practice Futures, Digital Fabrication and Future Practice was a research project commissioned by the Architects Registration Board of Victoria in Australia. The project set out to investigate the challenges and opportunities that arise out of the increasing adoption of digital fabrication within the design and construction industries, specifically focusing on professional practice in the architecture discipline in Australia. Digital fabrication refers to the manufacturing of three-dimensional objects from digital files using additive processes such as 3D printing or subtractive processes such as milling, laser cutting, etc. Rather than undergoing a process of translation to produce drawings or specifications for construction by a third party, objects are produced directly from the design in a one-to-one relationship. Over the last 20 years, an enormous amount of research has been undertaken both in the academy and practice into the development of the technologies associated with digital fabrication. Research-based practices such as Gramazio Colla in Switzerland, and more locally, Studio Roll & Snooks, ARMA, and Power to Make, have developed, amongst others, have explored the construction process optimization and novel tectonics made possible by the development of new tools and digital workflows. The technology is largely ubiquitous in architectural schools and increasingly so in practice. 3D printing and other approaches to rapid prototyping are commonplace, and more firms are engaging in the direct manufacture of building components. This trajectory, coupled with recent advances in architectural robotics, point to a future of fully automated construction. Despite this, the Practice Futures documents indicated that very little work has been undertaken worldwide into the implications of this shift on the legal, economic, ethical, or other non-design domains of architectural practice. The National Centre for Competence in Research, NCCR, on digital fabrication at the ETH in Zurich has established a socio-economic working group to examine the broader implications of digitalisation in the construction sector. While it is nascent, its work to date has principally focused on the impact of technological change on the construction industry rather than the design sector. While the automation of the construction industry will have an obvious impact on who builds buildings and how they are built, the impact on the procurement of buildings has largely been overlooked. The adoption of direct manufacturing suggests a dramatic collapse of the construction value chain. Rather than producing representations, the architect finds themselves providing direct instruction for production, or code. This shift would result in an unprecedented level of control for the designer over the built outcome, but at the same time signal a dramatic increase in responsibility and risk associated with design work. In recent years, the profession has focused on risk mitigation through the deferral of responsibility to the client, consultants, and contractors. The acknowledgement and acceptance of risk fundamentally changes the business model of architecture. The role of the architect has changed dramatically over the last 50 years. Whereas previously the architect was singularly responsible for the design, procurement, and delivery of a building, this position has gradually been eroded over several decades. The emergence of specialised consultant groups or new building professions such as project management and the increasingly litigious nature of the construction industry has resulted in a reduction of the overall scope for architectural services and a commensurate reduction in the revenue share for architects. Within the profession, this change has been accompanied by a great amount of public hand-wringing. However, there can be no doubt that the model of practice that is endorsed by professional bodies such as the Australian Institute of Architects and taught in schools is fundamentally complicit in this process. To adapt to technological change, the model through which architectural practice is carried out will have to adapt and evolve. However, what is less clear is what that model might be. Digital fabrication one of a number of major technological shifts that are disrupting the procurement of design and construction. As such, it is impossible to describe a single approach that would allow architects to be across all emerging technologies and markets. What this suggests is that the future of architectural practice might be a far more diverse understanding of what constitutes architectural service. As a part of the Practice Futures project, a survey of Australian architectural practices engaging with emerging digital fabrication technologies and processes was undertaken. What this indicated was that the development of these technologies had resulted in a proliferation of newly specialised practice types. This included practices such as ARMA that were solely focused on the development of design concepts produced by other architects for material optimisation and direct manufacturing production. Firms such as Studio Roland Snooks have focused on the development of new building materials through robotic fabrication. Others, such as Mart Studio, have absorbed design and manufacturing within a single entity, adopting the model of furniture or product design. These observations describe an ecology of new practices with individualised and entrepreneurial approaches that resist the orthodoxies of the traditional architectural model, and that engage with new technologies, new market shares, and risk. If this is the future of architectural professional practice, how do we develop a model that describes these kinds of diverse approaches? And more importantly, how do we teach it to the next generation of practitioners? The Masters of Architecture program at RMIT University includes 3 units of professional practice across a 2-year program. To maintain our status as an accredited architecture program in Australia, we are required to cover a series of core competencies that describe the traditional role of the professional, processes of project procurement and delivery, practice management, as well as the legal, financial, and ethical issues that affect practice locally. Most of this material is covered in the first 2 units, with Professional Practice 1 describing the traditional role of the architect in small practice, and Professional Practice 2 exploring an expanded view across large-scale and multidisciplinary practice. The 3rd unit in this suite offers a unique framework in the context of architectural teaching in Australia. Professional Practice 3 is focused on how technological innovations, digital frameworks, changing markets, etc. might affect the nature of architectural practice in the future. Students are challenged to operate in an entrepreneurial fashion to speculate on possible futures for architectural practice, with a focus on evolving the business model of architecture.
One of the underlying speculations in the development of this course is an observed similarity between the processes of research through design and business planning. In particular, the notion of modelling speculative propositions is a key mechanism for the evaluation of options in both contexts. In Professional Practice 3 at RMIT, students are encouraged to design through the medium of business planning, equipping students with knowledge of business terminology, standard reporting tools and formats, and how to apply this knowledge in developing a model for a sustainable design-oriented business. At the start of the course, students are introduced to the challenges facing architectural practice in Australian and international contexts by an introductory face-to-face lecture. A series of interviews with Australian architects who are innovating in their use of digital tools are also made available to students via RMIT's online learning management system. This frames the issues in local and tangible terms for students and provides an overview of how current practitioners are addressing these issues. Students self-organise into groups of 3 and undertake a series of case studies identifying design practices, both in Australia and internationally, who are innovating in their use of design tools in each of the following areas: communication and collaboration, design tools, and fabrication and procurement. The practice innovation case studies form a collective body of research which students draw upon in identifying their own innovation or an application of an observed innovation, upon which they incrementally model a business proposal over the subsequent weeks in consultation with their tutors. These business proposals include a description of the proposed service and examples of how the service is to be implemented, a description of the value of the service to be offered, a description of the pricing structure of the service, that is, how it is charged for, by what unit, hourly rate or percentage of the total cost or other metric, a description of the market for the service, and an articulation of a marketing strategy, the identification of startup costs, and the unitized cost for delivering one unit of the proposed service, and the identification of any risks, both financial and litigious, relating to the proposed innovation and/or service that is to be offered. Over the course of the last several semesters, a number of themes have emerged in the types of innovations identified and the business models presented, including the use of computational tools, including machine learning or artificial intelligence, as a mechanism for evaluating large data sets and identifying new project opportunities or client relationships. One of the best examples of this approach is Laura Vanier, Stephen George, and Giovanni Gunawan's proposition for a computational evaluation of allowable planning envelopes within Milbourne, referenced against existing building envelopes and historical sales data for individual sites, identifying individual or aggregate sites of very high development potential. The business model in this case offered customers a report of selected areas within Milbourne as a loss-leading service as a mechanism for establishing relationships with prospective development clients and with subsequent engagement for the architectural services on a project. This back-ended the profit generation in a more conventional design service. Interestingly, since this proposal was presented approximately 2 years ago, a number of businesses have emerged in the Milbourne context offering similar or related services. Another thematic that has been in the expansion of architectural practice into fabrication through the application of digital or advanced manufacture. An example of this approach is James Parsi, Alexander Christos, and Thurston Empson's proposal for XYZ, which identified a niche for the resolution and development of complex geometry components or assemblies in advance of large-scale production by others as a specialized fee for service. Several projects have also investigated applications of blockchain technology. An example of this approach is Simon Sawyer, Chris Crawford, and Youngbang Zhu's proposal, ProTales, which involves the expansion of conventional architectural practice to monetize the practice's back catalogue of construction details. While standard construction details are widely available and published in publications such as Detail Magazine and others, there are very few publicly available construction details based on Australian construction methodologies, which are significantly different to European or American approaches. In this business model, a catalogue of details are made available to other architectural practices via micropayments, enabled through the application of blockchain to manage licensing. Specifically, blockchain allows for highly secure licensing at a significantly lower cost than traditional centralized licensing due to its distributed nature. This lower licensing management costs enables extremely low cost per transaction in the range of 5 to 10 cents per application, which aims to increase volume over individual return per sales unit. In this case, students proposed that this service was an adjunct to a conventional architectural practice that delivers value from a key piece of practice intellectual property that conventionally lies undercapitalized. Another theme has been in the adoption and integration of virtual reality or augmented reality in changing the way that designers communicate design intent to clients and/or contractors. An example of this is Michael Vieira Lopez, Montgomery Balding, and Eleanor Morgan's proposal, Design and Construct, in which they propose for the elimination of 2D project documentation via the application of augmented reality representation of a detailed 3D model for use by construction trades on site. The core observation in this proposal is that current workflows in design develop complex and information-rich 3D models, which are then represented in 2D for the purposes of contract scope definition and for use by construction trades. This process loses a significant amount of information from the 3D model, which in turn leads to errors on site, and is also extremely time-consuming for designers to produce. The proposal identified a specific subset of clients who are integrated developer builders who would appreciate the value of the application of AR on site to expedite construction on site and reduce errors. The identification of this market niche allows for the proposed business to market their services based on this advantage rather than any efficiencies in the design process, allowing the business model to retain these improved efficiencies and therefore profit for the use in other areas of the business and/or distribution to shareholders.
As architectural practice enters a period of accelerated change, it is vital for universities and professional bodies to develop an open understanding of what might constitute practice in the future.